Yeah, so we are looking at the complex numbers and the integration. Yeah, as I defined, a complex number, okay, is defined as the square root of -1. Good. Now, I ask you to check from your calculators what the square root of -1 will be. Okay, and once you do that, it should give you a math error. Okay, and the only way to find the correct answer is to put your calculator in the complex mode. Okay, and once you do that, when you find the square root of -1, you are sure to get the value I. Good. So as a first example, I said if we are finding the square root of, say, a number like -4, this can be expressed using the rules of sets, okay, as -1 times what? The square root of what? 4. Okay, good. But we know that the square root of -1, as we defined, is I. Good. And then the square root of 4 is what? Plus or minus what? 2. Okay, so this gives us plus 2I, and then minus 2I. Okay, so these are the answers for this particular expansion. Now, moving forward, we want to try some more examples. Okay, the first example will be this square root of -5. That also can be re-expressed as square root of -1 times the square root of what? +5. Okay, and we know that this is I. This is the complex number I. And then √5 is a set, so it remains square root of 5. When we come to the next one, we have minus square root of -7 can be expanded as -1 times square root of what? 7. Okay, 7 is also a set, so we have minus I. Okay, minus I root of what? 7. Good. In the same light, we can also solve this as square root of -1 times the square root of 9 times the square root of what? 11. Okay, and this will be I times what? Plus or minus 3. Okay, times what? The square root of 11. Good. So this will give us plus 3, okay, I root 11 plus 3I root 11, or minus 3I root of 11. Okay. Yeah. Now, want to try more examples, okay, to understand what this complex numbers actually mean. Now, the next thing we want to look at is the concept on the powers of I. And I want you to take note of that at your end. I raised the power 1 is I raised the power 2 is square root of, is what? -1, sorry. I raised the power 3 is -1. It's negative I, and the I raised the power 4 is 1. Okay, let's just see how this came about. So if I is square root of -1, then the square of I, okay, per the rules of set, this square and the square root will cancel out. So you get what? -1. Okay, cool. So that is how come we are getting the values we are getting. Then I cube is the same as I squared, okay, times what? times I. Okay, good. So if I squared is -1, then times I will just give us what? -I. Okay, good. Okay, okay. So that can be easily proved. Now let's move on to the next stage. Now the next thing we need to understand is the fact that complex numbers consist of both real and complex or components. Okay, in the sense that the complex number system itself comprises of the real, okay, numbers and imaginary numbers. Okay, so all the numbers we are seeing with I are called imaginary numbers. So assuming I give you a complex number like 3 minus 4i. Okay, this is a real number. 3 is a real number. Good. So we call it the real component. And then 4i is imaginary. So we say this is the imaginary component. So every complex number is made of what? A real and a imaginary what? Component. Okay. So we take note of that. Good. So these are, I think we've seen these examples already. Let's move on. I want us to do addition, and there are more examples in the slides which I'll be sending to you. But this is what I just explained. So every complex number is made of a real, okay, component or real number and an imaginary number. Okay, good. And the real number is the part A, whilst the imaginary is the BI. Okay, so want to add and subtract uh, complex numbers. Okay, now anytime you are adding or subtracting or multiplying, treat them like you are dealing with variables. Okay, just like you add 7x plus 9x. Okay, do same here. You understand? So when you see 7i and then 9i, just add 7 plus 9 will give us what? Will give us 16. Okay, so you get 16i. Good. Yeah, so on multiplication, like I was saying, you multiply like you just doing algebra. So -1 times 3. Okay, the -1 times I. And then once we expand, -I times 3 will give us -3i. The -I times I will give us -I squared. Okay, so now -3i. Then we know I squared will give us what? -1. Okay, good. So minus times minus will be positive here. So we end up with +1 minus what? 3i as the final answer. In the same light, if we're expanding here, or when we are multiplying, it will go this way: 2 times -6, which will be -12. Then 2 times -1, which will be minus what? 4i. Then we have 3 times 6, okay, which will be -18i. Then we also have 3 times 2i, which will be minus, there's a negative here, so -6i squared. Okay, so this will give us -12, -4 minus 18 will be -22i. Then we have -6 times -1. Okay, so this will give us -12 minus 22i plus 6. Okay, good. Now -12 plus 6 will give us -6. then minus 22i. So this is how multiplication is done for complex, okay, numbers. It's just like you are working in algebra, normal algebra. Okay, good. Now let's finalize with some questions on division of complex numbers as well. So like we said, in class today, we are going to just introduce ourselves to this concept. Okay, and we can further from there later. Okay, so when it comes to division, what we do here is if I ask you to simplify, okay, 3i over 2 minus 5 minus 2i, okay, we'll treat it like we are working with sets, okay? So when you have a set like 2 root 2 over, say, 3 minus 4 root 2, okay, what we do is you multiply the numerator by the conjugate, which is 3 plus, okay, 4 root 2, the conjugate of the denominator over 3 plus what? 4 root 2. Then you go about your multiplication. Yes, in the same light, we're also going to multiply this by the conjugate of the denominator, which is 5 plus what? 2i over 5 plus 2i. Okay, good. And when we expand this, that should be very simple. So let me make it 3i, okay, times 5 plus 2i, okay, over 5 minus 2i times 5 plus 2i. Okay, then we can expand. 3 times 5 will be 15i. Then 3 times 2 will be 6. Okay, 6i raised to the power 2. Then divided by 5 times 5 will be 25. Then 5 times 2i will be 10i. So plus 10i. Then we have 2 times 5 will be minus 10i. Then we also have 2 times 2. Mind you, there is a negative here. So we have minus what? 4i raised to the power what? 2. Okay, good. So in the numerator, we have 15i plus 6 times what? Negative 1. Because I squared is minus 1. All over 25 plus 10i minus 10i will go to 0. Then we have minus 4 times negative 1. So this will result in, this will give us 15i minus 6 over 25. Okay, plus what? Plus 4. Okay, so then our final answer, let me write it here for the sake of those who might not see from the bottom. So final answer will be 15. Let's rewrite the real term first. So we'll get negative 6 over 29 plus 15i over 29 as our final solution. So that will be our final answer for this question. If there's any question, you can lift your hand and ask.